Hi everyone, I'd like to talk to you about what's new in Dart analysis, what's up and coming, and how we at Lincode are preparing for the changes. First, a little bit about myself. My name is Piotrek. I've been a Flutter developer for, let's say, 4.5 years. I've been working at Lincode ever since. I love playing around with new technologies. I love exploring new possibilities, new tooling, especially around languages themselves. And in my free time, I like learning foreign languages. Right now, I'm really into Japanese. So what's on the agenda? What we will be talking about today? First, a little recap as to why lints matter, what even are lints, how to use them, what they can do for us, and how to integrate lints in our developer workflow. Then I'll showcase the new plugin system and its possibilities, and how it can streamline our workflow even further. And then we'll go step by step, pretty much, how to take our existing lints and how to take advantage of the new system while keeping the existing implementation and what can be done with the new system. So first, what are lints? These are all the red and yellow squiggly lines, basically, that we see in our IDEs. They are automated code checks. They can check for common bad patterns. They can prevent some common issues easily, like issues about nullabilities or issues that can simplify the code. So lints basically are automated code checks that don't run the code. They just read the code and understand it. That's why they are instant. As you type the code, you get the feedback in the IDEs or in the terminal. You also get the same feedback on CI. And in this day and age, with the AI agents and all of that, they can take advantage of the lints as well, especially with the Dart MCP, which can analyze the code for the AI agent. It creates a very tight feedback loop where the agent can continuously analyze the code, see what can be improved, and apply these changes without any of the developer's input. So it really simplifies and makes the entire developer experience much simpler and quicker. Together with lints, another, let's say, definition that needs to be mentioned are fixes and assists. Once lints analyze some piece of code and they find an issue that they know how to fix, they can provide you with a suggestion. For example, well, this variable is not used. You can just remove it. You can just click this button. These are all the yellow light bulbs that you see in the IDEs, and they can simplify the code for you without you having to type any of the code. Another thing are assists. These are not fixes for specific issues, but they are just quick actions that you commonly do when you code your application. In Flutter, we have a lot of assists that wrap widgets in another widgets. For example, here you can wrap a widget with a builder, you can wrap it in a column, stuff like that. These are assists, and they are available pretty much everywhere the code is available without any issues. Fixes need an issue to fix. So what are custom lints then? Because the Dart SDK and the Flutter SDK comes with a predefined set of rules that encode the standard and common practices for Flutter and Dart. But sometimes when you are working in a big team, not necessarily even big, but just in any kind of environment that has its own preferences, has its own stance on certain issues, you want to enforce them automatically. You don't want to open every PR and write the same comment every time. Hey, we at this company, we do these things a certain way. So custom lints allow you to encode those additional guidelines so that they are all also automated. These go beyond the official lints, and they can encode the architecture that you use internally in your company, as well as propagate your beliefs, your beliefs system and your best practices that you worked on at your company, and you want to distribute them onto other people, so that you might want to encourage them to write the code in a way that you perceive as efficient or looking nicely, because a lot of lints are just about the code looking clean and efficient. What can custom lints do for us? For example, you might want to encode specific naming conventions in the code. These are inherently not universal because different teams will have different naming conventions. But once you are in a team, you want to make sure that, for example, every qubit ends with the word qubit. If you are using hooks, the package Flutter hooks in your app, but you suddenly refactor the code in a way that the widget doesn't use any hooks anymore, you might want to have a lint that will tell you that this widget can be simplified even further because it doesn't use any hooks. It's an optimization and a good practice to only use the hook widgets when you actually use hooks. So this lint can automatically flag and fix these usages as you type. Another, in my opinion, the most powerful example of a custom lint is enforcing architecture standards and usage of specific classes in the code. For example, you can require that the design system items are used appropriately. And if your team has, for example, a very specific design system with custom classes, custom widgets, you might want to enforce that every developer and even AI agents only use those specific classes. As you can see in the left example, this is an example of one of our flagship, let's say, custom lint in our package. This is the lint that you can configure and specify that, for example, instead of the widget text, you have to use the widget app text from our design system. As you can see, you also have very clear feedback in the IDE and an action if you want to ignore the lint, you always can. But this will be an explicit usage of the basic material text instead of your custom app text that can come with additional logic or additional UI. So it really simplifies the workflow, both for the developers because they have constant guidance what to use and constant guidance how to make their code adhere to company standards or the current project standards. As I said, it's also very important for AI agents because you don't have to prepare as many rules, prepare as many guidelines for the AI. They can just look at the lints, look at the output of the analyzer, and they can automatically know what's wrong with their code and automatically fix it for you. So now that we know what custom lints are, why am I talking about the new plugin system and what it's for? The new plugin system was mentioned today at the keynote, so I'd like to expand on what this plugin system is and what it can do for us. Basically, in a nutshell, it's a way to write custom lints as a first-party plugin that's integrated in the analyzer process. It has a super simple setup because it uses one command. It ties directly to the native Dart analyze command, so that once you run or invoke the analysis in the IDE or on CI or through the terminal, you always get both the standard lints that are provided by Flutter and Dart, and both your custom lints that encode your company and architectural preferences. As I said, it's a unified experience. The usage is just through the Dart analyze. This is crucial for AI agents because before, with the legacy custom lint plugins, you would have to either tell the AI that, hey, there is a separate plugin that you have to run via the terminal to get all the custom lint information. Specifically, before it was, I think the most popular was the package custom lint made by Remy Rousselet. And it's amazing, and our Lincode lint package is still based on that package, but it has to be executed separately. With the new plugin, you don't have to run anything else, so the AI agents can take advantage of this new setup as well. That being said, this plugin is still work in progress. It's not fully fleshed out yet. There are certain limitations or different architectural decisions. So I do encourage you to keep track of the progress. There is an umbrella issue that tracks what is being done, what is yet to be done, what are the decisions. There are links to documents and further reading. Some of the limitations that, in my eyes, are still outstanding and yet to be improved upon is that the configuration of the lints is limited. If you want to, as a developer of the lint, you want to tell that this lint should be very important and should have a warning severity by default, that's not available yet. They are all info warnings, but that's I would say, a minor issue that can be fixed in the future. One of the, let's say, trademark features of custom lints before was that you could provide custom lint config through the analysis options, so that you can specify your preferred settings for the lints. This is still this is also missing, but we'll get that hopefully soon. So now let's look at how to migrate from the custom lint package, how it was done before, and how to create your own linter plugin yourself. Overall, the migration is not that painful, luckily. The steps are pretty simple and can be automated, for example, with an AI agent. But overall, there are still some crucial changes as to how the plugin even works and how it needs to be reasoned about. But first, you have to define the plugin itself. With the new system, they all live, you create a separate Dart package that has a very obvious entry point called main Dart, and it exposes a single field called plugin. The reason for that is that with the new analyzer, the analysis server creates a separate project in your home directory for all the enabled plugins and runs each of them as a plugin to the current analyzer. That's why you need to expose the plugin class and the plugin object so that it can be run. Just as before, you register your rules that you want to have reported as warnings, and also assists that you want to have available if you want to write custom assists that are these extra code actions in your code. Luckily, the migration of each of the rule is pretty simple, I would say. What's most notable about this step is that, as I said before we could specify the default error severity. With the new system, it's not available yet. These are all default to info. But other than that, you also specify a unique name for the lint and a description so that the users can know what's going on and what is actually being reported. The main part of a lint is to read the code, and I think this is the biggest change from the package custom lint, because before it was based on callbacks. It was much simpler. You just had to invoke add something, for example, add class declaration, and you were able to analyze this all the data from the abstract syntax tree in a type-safe manner and with full access to the standard Dart library. With the new system, it's much closer to the standard Dart analyzer, which implements the visitor pattern. It is, on the first glance, much more boilerplate, but it does allow for a more powerful analysis. There are many different visitor types, so that you can tweak your analysis to your specific use case. Reporting results to the user is pretty much the same, I would say, other than, well, you can still analyze specific tokens. You can analyze entire nodes, which is, for example, class declarations. You can analyze very specific parts, and you can tweak where those yellow squiggles appear in the code. You can report through the rule object that you defined, and the API is pretty much the same. You can specify additional arguments so that the message can be customized further. Another big change, I would say, is how to define fixes and assists. These are now unified as a one correction producer. The only difference is that fixes will have a diagnostic available that will tell you what exactly was triggered by the lint and what can be fixed. And assists will not have the available lint to go back to, but instead they will have the available node that the user clicked on and told the IDE, I want to do something on this piece of code. But other than that, all the previous Dart Analyzer API is still available. You can still create very rich changes, since you have the access to the change builder and the Dart file edit. You can create many complicated changes in different parts of the code just from one correction producer. This gives the ability to create very rich and dynamic changes in the code just by one click of a button. And finally, how to use it in your project. Before, you would have to both define the final package you would use that provides the lints, as well as the package custom lint itself, because this is the package that actually runs the code. And as it's presented at the bottom, previously you would have to run two separate commands. With the new project, with the new system, you just have to run one command, and all the lints, both the built-in and the custom ones, get reported. The updated lint package is now available with the new system. I strongly encourage you to try it out in your project. The setup is very simple, and the analysis is much quicker and much more convenient. At Lincode, we expected this change beforehand so that our Lean AI can actually use those lints automatically out of the box. And our Lincode lints are also a crucial part to our workflow in creating Flutter apps, as well as migrating existing teams to Flutter. These lints encode our own architectural standards, so that this migration is even smoother and even more convenient for existing teams. I do encourage you to check out our ebook, which lines out all these steps in migration and where these lints can help you migrate existing non-Flutter apps or carry you further in your existing migration to Flutter. Thank you. If you have additional questions, you can either ask them here via the microphone or at our Lincode booth. That's just around the corner. You can also reach out to me via LinkedIn, and we can talk about the lints further. Thank you very much.